Welcome to the Spectral Tools introductory video. We are going to be going through how to do some basic target detection using the Spectral Tools, which are written in Python, available, and it is executable. So you double click on the icon for the executable. As the software opens, it will open this window here as it's loading, and then it'll create this toolbar here. Information and output error messages, if there are any, will come out to this window. We'll minimize that and get it out of the way. We don't really need it. So this is our Spectral Tools toolbar. All of the functionality within the Spectral Tools can be accessed from this toolbar. First, let's go through opening a simple image. And so I have a couple of images, or a couple of data sets, one image, one library, on my desktop. So we select the image, and then this is the image we've selected. We can zoom, we can change the window size. I'm zooming in or zooming out with the mouse wheel. If we click in the image, we'll get a spectra. Let's move that out of the way. We can click, pick up a few different spectra. If we want to change the names of the spectra, we can go through. The first one was a field, the second one was trees, the third one was soil. So we can change the name of the spectra. So that's basic functionality of the viewer. We can change our stretch. We can change the bands that we're viewing. We can change single band or RGB. If we want to do an interactive stretch, we can do an interactive stretch here. Suppose we want to stretch the blue band. We could do that. But we're going to do some target detection. So we showed how to open an image. Now we're going to see how to open a library. So here's our Polymer library. This here is our library viewer. This is our library manager. So we can click on a spectrum here, and that'll plot the spectrum that we're looking at here in a spectrum viewer. This will give us a list of all the libraries that we have open. If I had more libraries open, it would add them to the list. It tells me information about each library, like the number of spectra, the number of bands, the scale, the wavelengths, etc. And if I want to open up one of the libraries, I just click it on it there. I can minimize those. If I want my spectral library manager, I just click it there, and that'll bring me all the libraries that I have open. And so now let's go ahead and do some target detection. So let's do ACE, and we're going to use this average image. It's over Northern Virginia, west of DC, and we're going to look for polymer. So we'll open a polymer library, and they say choose an output file name, and the default output file name is ACE. So why don't we just go ahead and go with that. So now it's doing target detection. It's automatically resampling our library to match our image. The image was atmospherically corrected with Quack, and so it opens our output. It gives us a little information GUI, says here's the image, here's our library, 6 spectra, and ACE was completed. Okay. So there's our target detection. We probably want to be able to compare that to our image. So we'll reopen the image. We didn't have to close it to run target detection, and now we want to link the viewers together. So we open the link viewers, and this tells us rows and columns to check to make sure we can link those viewers, and of course we can. And so now they're linked. So as we zoom in one, or resize the window for one, it will resize the associated linked viewer. We can toggle back and forth. I'm interested in this white spot right here, so we can go through and look at that white location. And something's white right there, so we can click on that and get a spectrum. And we could click on it over here in the ACE plane and get a plot of the ACE scores for our different spectra in our library. Something we can do as a quick convenience is display the max band for this pixel. You'll notice originally it was HDPE here, high density polyethylene. The max ACE score occurred for low density polyethylene. So this is telling us this had a maximum ACE score in our library of low density polyethylene. We can go into our library manager and get the library we used, and let's plot HDPE, and let's select the HDPE and LDPE spectra, and then we can paste them in this viewer along with the spectrum from that region. So that's a quick way to be able to compare those to the spectra we have from the region. If we want to do a little bit more viewing of some of these maxes and mins, we can zoom in, and then we can do common scale and window, which will rescale all the spectra to the same mean and standard deviation in the window we're looking at. And so the blue is the pixel, and then the green and the orange here are our different library spectra. And so you could look at the max and min and whether they seem to line up with one or the other. And they seem to be decent matches for both. Clicking on this pan tool allows us to drag spectra. If you left click, if you right click and pull, you can move the right click and drag expands in one direction or another. Left click and drag moves. Let's do let's look at this drop off in these features, and then common scale in this window. And at this point you see that our pixel maybe has some of the features here that are better matched to LDP than HDP, but it's not clear which is a better match. So in the next video, we're going to go into the material identification tool, which would allow us to do a better job of identifying the material that's based in this white region here. Thank you very much.